Okay, when two lines cross, so with the exception if they're parallel, but all other lines that aren't parallel, at some point they're going to cut each other there. Okay, what we're actually doing here is using the graph of two lines to solve what are called simultaneous equations. So we're finding a value of x and a value of y, which simultaneously solves that equation and solves that equation as well. Okay. This is what's called a graphical solution to simultaneous equations. In stage 6 you'll come across the algebraic solutions there. Now you can see if two lines are parallel, they just keep going forever. They never meet, so there's no solution to simultaneous equations if the two equations have the same gradient. Now we can check if a particular value happens to be the point of intersection by substituting it into both of the lines. If it satisfies both of the lines, then it is the point of intersection. So in part A, so for line 1, you can do that as a curly L if you like. The left hand side is just the y value, which is 1. The right hand side is going to be 2 lots of the x value plus 3. So that's equal to 1 as well. So we know minus 1, 1 is on the first line, so L1. So for L2, again the left hand side is just the y value again. The right hand side is minus the x value, which is equal to 1. Again they're on, it's on that line as well. So because this point is on both L1 and L2, so therefore minus 1, 1 is the point of intersection . Actually, you can just leave it as that, saves writing anything more out. Okay, so for the next one, so for L1, the left hand side again is just the y value, which in this case is equal to minus 4. The right hand side is equal, okay, rightio. So what we've got to do here, the right hand side is equal to minus 2 times 2. That's also equal to minus 4, so it's on the first line. For the second line, the left hand side is equal to 3 lots of the x value plus 2 lots of the y value. That's going to be 6 take away 8, 8 is minus 2. The right hand side is equal to minus 4, so therefore it's not on L2. So look, it's on this line, but it's not on that line, so therefore 2 minus 4 is not the point of intersection. Okay, we're going to solve the simultaneous equations y equals 2x minus 2 and x plus y equals 4. So the first one has got a y-intercept of minus 2. It's got a gradient of 2, so for each one it goes to the right, it goes up 2. So it'll pass through those boxes there. This is where I wish that I had a ruler. Now, here's a skewer from the kitchen. One could say it's an obscure way to draw a line. Yes, got a pun in. Excellent. Should have been doing that for a while. There you go, both the puns and the skewer. Okay, so let's write that out. So that's y equals 2x minus 2. That's cutting at minus 2 and at 1. You notice I haven't quite got this one here. I haven't quite got it right. Okay, x plus y equals 4. Again, you can rearrange that by moving the x to the other side. So it's going to cut up here at 4. It's got a gradient of minus 1. So each square you go across to the right, you're going to drop by 1. So look, at a glance I can see that's going to be the point of intersection, but let's go through and graph it again. See if I can get it a little bit better than last time. Okay, so that's x plus y equals 4. You notice because I've drawn two lines on the graph, I've labelled those lines, as opposed to previously where I've just had the one line and I haven't labelled those. Okay, so that's going to be 2. This is going to be at 2. So we can say the solution is 2, 2. Look, you could have written x equals 2, y equals 2. That's fine. So you can see the importance of having some grid paper and using something straight, preferably a ruler, but a skewer from your kitchen if you, there you go, I'm sure you can find something at home that's straight if you, for whatever reason, don't have a ruler. Okay, we just need to find the coordinates of the point of intersection. So here you can see that's 1 across and 3 up, so 1, 3. For the second one it's -1, 2. Let's write this one down the bottom so you can see it a bit more easily. And this one here is going to be 2, 2. There's no great difficulty there. We need to work out whether 1, 3 satisfies these equations, so we're just going to substitute into each one. So for the first one, the left-hand side is just the y value, which is 3. The right-hand side is 2 lots of the x value plus 1. That's also 3, and therefore, yes, it does lie on the line. I won't write that all out there. For b, the left-hand side again is equal to the y value. The right-hand side is going to be equal to minus the x value plus 5, which is equal to 4. So they're not equal, so no, it's not on that line. This next one, the left-hand side again is the y value. The right-hand side is going to be minus 2 times the x value minus 1, which is minus 3. Again, they don't match up, so no, it's not on that line. Again, for this last one, the left-hand side again is the y value. The right-hand side is 4 lots of the x value, take away 1, which is equal to 3. They are equal to each other, so yes. Okay, firstly, apologies, you're only doing A, C and E here. I haven't blanked out the rest of the question, so my apologies there. Okay, we want to see if 1, 3 lies on each of those lines. So if it lies on both of them, then yes, it is the point of intersection. So for line 1, we can say that the left-hand side is the y value, which is 3. The right-hand side is going to be equal to 1 plus 2. That's a true statement, so yes, it lies on L1. So for L2, we're saying y is equal to 3x, so 3 is equal to 3 lots of 1. Again, that's a true statement, so therefore 1, 3 is the point of intersection. I've just done some abbreviated working because I'm going to run out of space here. Again, for L1, the left-hand side is going to be equal to 1. The right-hand side is going to be minus the x value plus 3. Now, that's 1, so yes, it is it does lie on that line. For the second line, the left-hand side is just the y value. The right-hand side is minus the x value. Now that's not a correct statement because 1 is not equal to minus 2, so therefore 2, 1 is not the point of intersection. And for E, again for L1, the left-hand side is going to be x plus 2 lots of y, so 2 plus 2 lots of 2, that's equal to 6. Okay, that is equal to the right-hand side, so good, that's all good. For L2, we've got 3 lots of x minus 4y on the left-hand side. So 3 lots of 2 minus 4 lots of 2. Now that's got to be equal to minus 2, and that does work out. So again, it's on both lines, so therefore 2, 2 is the point of intersection. Okay, we're going to find the points of intersection of y equals x minus 6 and y is equal to minus 2x. So this first one will fit on. I'm going to make this minus 6 here, so I'm going to go up and down by 2's. So the y-intercept is minus 6. Now, what I want to do to basically, that's now going to be like 2, 4, 6, etc. So what I'm going to do here is, you can see that the gradient there is 1, so like I could go across 1 and up 1. That's the same as going across 2 and up 2, and you can see I'm going to pass through those lines. Again, if we get our trusty skewer, this is where a steady hand can make this work a bit easier, and a ruler. That's on my shopping list for today. As you can see, I've just missed, so my answers are going to be out by a little bit. Okay, the other one, y equals minus 2x. So that's like y equals minus 2x plus 0, so our y-intercept's there. If we go across 1, we need to go down 2, and luckily there's our point of intersection anyway. So this time, because we know that's the point of intersection, I don't really need to worry too much about how accurate this line is. Pardon the finger. This is why I use a ruler, not a skewer. I figured I'd leave those in there just for the hell of it. Okay, so you can see here, here's our point of intersection. That's going to be at 2. This will actually be, I was incorrect there, don't forget I changed the scale there, so that's going to be 4. So we can say that the point of intersection is 2 minus 4. You can always check it in the original. So is minus 4 equal to 2 take away 6? Yes, it is. Is minus 4 equal to minus 2 times 2? Yes, it is. So we do have the correct solution. Okay, this time we've got y is equal to x plus 2 and y is equal to 3x minus 2. I'm just going to check and see what my scale needs to be. So if I go 3x minus 2, yeah, that should be good. So I'm going to use a 1-to-1 scale here. So x plus 2 has got a y-intercept of 2. It's got a gradient of 1, so each time it's going to go across to the right and up by 1. So I want my line to pass through there. This is the advantage of using grid paper, in that I could just more or less plot the dots and then be a bit more careful when I go to draw it. I was going to do it by hand, but no, let's use my favourite skewer out of the whole kitchen. I'm going to get a ruler this morning when I go shopping. It'd be my big adventure there. Okay, so then we've got y equals 3x minus 2, so we're going to have a y-intercept of 2. The gradient's 3, so for each 1 unit you go across, you come up 3, and look, straight away we can see that's going to be the point of intersection just there. But again, if we go through and, oops, can't wait to get a ruler. Okay, we can sketch that in. And again, we can see our point of intersection there, so that's going to be at 4 and at 2. Okay, so we've got 2, 4. Again, we can check that. So is 4 equal to 2 plus 2? Yes, it is. Is 4 equal to 3 lots of 2 take away 2? Yes, it is. Okay, so we've got y equals 3, which is simply going to be that horizontal line through 3. And then we've got x plus y equals 2. Again, if we like, we can rearrange that to make that y equals minus x plus 2. So it's going to cut through there at 2. It's going to have a gradient of minus 1. So each time we go across to the right by 1, we go down by 1. Again, straight away we can see there's our point of intersection, but let's just graph that. I'll try not to get a thumb divot in this one. Okay, there we go. So we can see at a glance that the solution there is going to be minus 1, 3.